Can everybody hear me okay? Awesome. How's everyone doing? Cool. I like this little face mic thing. I feel I should do like a Tony Robbins. Who's ready to get your life in order? So thank you very much for having me speak. Thank you to all the speakers before. This is called C# Run, and we're going to talk about C# stuff. So in this talk, we're going to go through most of the slides actually are going to be about what is .NET to begin with. You kind of hear it a lot. It's not always very clear to people, so I'm going to spend some time on that, which is really boring content, and then get into some demos about using it for offense and then detecting some malicious C#. And then that's it. This is a real current photo. I'm the one in the middle waving at you. So my name is Lee Kagan. I'm the Senior Principal Offensive R&D Specialist at Symantec, also the co-founder of Red Black Security, which is an offensive security shop here in Toronto, and also the co-founder of the C3X, which you heard about earlier. I'm on LinkedIn, but I ignore everyone that tries to contact me there, so if you want to get in touch, Twitter's the best place. I'm pretty active on there, and you can reach me at InvokeThreatGuy. All right, so what is .NET? Really, we're talking about the .NET framework and a lot of other moving pieces in it. It's basically a software development framework. It goes back to around 2002-ish with the very first version that came out. One of the big pieces of the .NET framework you'll hear about, even though there's many more pieces, called the CLR, the Common Language Runtime. And that kind of provides the runtime environment for a piece of C# code to actually execute on your system. When we're talking about C# and a lot of other things that are targeting the .NET framework, we're talking about managed code. And I'll kind of get into in a point or two about what that means. But when you think of traditionally unmanaged programming languages, C, C++, stuff like that, you're responsible for a lot of things that you're supposed to do, like garbage collection and dealing with memory and all that kind of fun stuff. So when you're dealing with managed code, it does a lot of that for you. You don't have to figure out how to do all that. Specifically things like threading, type safety, garbage collection, like I mentioned, those are all done for you behind the scenes with the magic that is .NET. You just write your fun little program, and underneath the hood, everything else is pretty much taken care of for you. Another big piece that makes the .NET framework, one could argue almost the most important piece of it, is what's called the framework class library. When you write something in C#, chances are almost everything you could think of has been written for you already in something called assemblies or classes. So this framework class library, this giant collection of stuff that Microsoft has already written for you, third-party people have added their stuff to things like NuGet Package Manager, where you can install fun little add-ons for your program. It really makes this idea of reusable, object-oriented programming very, very easy to get into and work with. And that's one of the reasons why I like it. So when you hear assemblies, we're not talking about assembly language or anything like that. We're talking about these class libraries. So when you compile a program in C# to like an EXE or a DLL, technically speaking, those are assemblies. So it's just one thing that can trip people up when you're talking about it. It's also not just for Windows. This has been true for a long time, but lately it's becoming really popular. I'm sure on Twitter some of you have seen people who do these fun little like, hey, I'm running Windows, which is running the Linux subsystem for Windows, which is running PowerShell that I then installed .NET Core on. And so it's no longer this kind of Windows-specific realm to live in. Things like Mono, Xamarin, I don't even know if that's how you say it, .NET Core, allows you to develop for other platforms. So you're no longer in this platform dependency with just having to build something that only works on Windows. It supports also, and this is like the shortest list of languages you can develop in, C#, C++ you can still work with, JScript, VBScript, PowerShell, obviously. And one of the big things right now is this idea of called bring your own interpreters, bring your own languages, like Booleang, Anton mentioned earlier, IronPython. So anyone that's played with Silent Trinity might be familiar with this. You can actually bring these new engines inside of the .NET framework and develop in them. It's really, really cool. I almost just let like a huge burp through the microphone. So some terminology, I just wanted to get through these because I figure if you do like C# and .NET and you get into it, you're gonna come across these, so I may as well bang out a few. The CLR, the Common Language Runtime, as I mentioned before, that's a biggie. That's the thing we're going to see in a diagram that actually handles the runtime execution of your program. There's also the CLI, not command line interface. It stands for the Common Language Infrastructure. This is a standard made by Microsoft to allow for other languages to kind of adhere to the same design principles so that you can work with them. Then there's a thing called the MSIL or the CIL, which is, the MSIL is really just Microsoft's version of this common intermediate language. And of course, Microsoft always has to do their own version. And really, that's what, when you compile a program in C#, it's actually getting compiled down to IL, to this intermediate language. Then you have the global assembly cache. This is kind of cool. It's sort of what we were talking about with assemblies and framework classes. It's literally a folder that has all of this shareable classes and libraries that you want other programs or other applications to maybe borrow code from. So if you wanted to put something in it, you would put it in the GAC. The other piece that makes it kind of cool is what's called the JIT compiler. This stands for just in time. So when you compile something and then you want to run it, the JIT compiler is actually going to kind of compile again at runtime down to native code, so down to your machine language. And then the framework class library, like I mentioned before, and there are so many more. .NET Framework really is a massive beast. Okay, so it's funny, it's 2008. I think this still stands true. Feel free to scream at me if it doesn't. This is essentially how you write in some C#, you compile it with the .NET compiler. So if you're in Visual Studio, you write a nice little Hello World program, you hit build, the .NET compiler is compiling that down into CIL. So that's your bytecode, right? Then when you want to run it, the CLR kicks in, and that's the common language runtime. So it's literally an environment that your program is going to run in. The just-in-time compiler is going to recompile that already compiled program down to machine code, and that's what's actually letting it run. So it's kind of a cool process. So here's a very basic example using Visual Studio of what a C# program looks like, and it's broken down pieces. Hope that's okay to read. I tried to blow it up as much as I could. You have at the very top a using statement. The using statement might sound familiar to people who use Python, like when you're doing an import. You're essentially saying, I would like to use the system class library. And the system class library is the top root of this hierarchical collection of libraries. So a lot of basic functionality is in the system top root level class, like printing to the screen. The thing underneath that is called namespace. And the namespace is really how .NET likes to structure and manage parts of code that are probably related to one another in some way. But when you create your own solution in Visual Studio, you give it a name, and then now that's the namespace for your application. After that, you have a default class, which will probably say something like program, unless you've changed it. And then in your program class, you're going to have your main method. This is the entry point to your program. And under that, what we've now used from our using statement, is the console class. And inside the console class is a method called writeLine. And underneath that is another class called readKey, which just waits for you to hit a key and the program closes. You compile that, you run it, and you get a little console application like this that says hello BSides TO. And that's really the basic building blocks of a C# program. Okay, right into some of the fun stuff. Now that we got that out of the way, C# for attacking. I come from no programming development background whatsoever. I kind of got a late start in that. And C# was the way I got into it, because the barrier of entry for learning C# is crazy simple. I heard that Microsoft Virtual Academy is going away or either may already be away. I did their free 101 C# course, and at the end of it, I started writing offensive tools. But before we get into that, PowerShell. So PowerShell isn't dead. Let me make that very clear. It's just so heavily defensively researched that as long as you have the capabilities in your environment, there's kind of very little excuses for why you can't pick up on a malicious PowerShell. I mean, there's no shortage of rules and detections and research and all that stuff. C# isn't really quite the same. There's not a lot of public research out there. There's some shops that are hoarding information they want to use in their EDRs and all that other kind of stuff. But generally speaking, it's kind of open season right now, which is why there is this insane rush of everyone porting their PowerShell tools over to C#, right? And now that's going to change. When PowerShell boom hit, everyone was freaking out. We can't detect this. It's living off the land. We got no logs. Microsoft fought back, and with the PowerShell version 5, we got script block logging and all this other fun stuff. So give it some time. That will happen. So like I said, learning entry to writing C# is crazy easy. If you want to get started with a programming language, I kind of recommend it. It's just very, very simple. Porting your PowerShell over to C#. So you got a tool you love in PowerShell, and you want to do it in C#, it's pretty straightforward. In fact, for those of you that have worked with PowerShell, you have worked with the .NET framework. You have interacted with it. And it's almost, not all the time, kind of one-to-one mapping. So if you just take the line in PowerShell you really liked, you can almost just copy-paste it in, and I'm using that very loosely. But it's not a big stretch. Like PowerShell, though, from an offensive perspective, we still get access to all that fun stuff that PowerShell provided, which was so amazing. Access to Win32 and the Windows API. You can do p-invoking, which is dealing with unmanaged code in managed code. So if you want to run some kind of C++ stuff, you can. And technically, we're still living off the land. We are now not just using the tools that are on a Microsoft environment or on a Microsoft system. We're actually compiling for the languages they wanted people to use. And there's so many different ways we can kick off our malware with using C#. So yeah, like I said, you can still access the Win32 APIs. You can still do your create threads, create remote threads, load libraries, virtual allocs, all that kind of stuff. It's still available to you. The public marketplace for offensive C# is massive. I can't keep up with it. Like every 2 days on Twitter, I see another tool, another tool, another tool. But some of the most notable ones are the Ghost Pack is probably my favorite collection of C# offensive tooling. It's written by the folks over at Spectre Ops, and really what they did was take a lot of functionality in other tools in PowerShell and said, let's just make C# versions. So you have the traditional Mimikatz everyone loves. Straight up using Mimikatz these days, depending on the environment you're going up against, is pretty risky. Touching Alsace is pretty risky. If it's getting by, that's definitely an organizational problem, but there's kind of no real reason to have to rely on Mimikatz anymore. So they have Safety Catch, which is a port of just certain functionality in Mimikatz, not the whole thing. You have Rubius, which is a port of Kakio, another project from Ben Delpy that does Mimikatz, and that deals mostly with Kerberos abuses. You have SharpView, which is a port of PowerView. PowerView is one of the best collection of PowerShell modules for reconnaissance and all that stuff ever. So now you have it in C#. And then you have Seatbelt, which is a really cool situational awareness program. You can just run it and say full, and it'll tell you all this cool stuff about the environment that you're in. Covenant is a really, really cool new C2. 2019, by the way, is like the year of the command and control framework releases. They're just coming out of the woodwork everywhere. It's still early in its inception, but it is really awesome, and I believe it's entirely written in .NET components. So not just C#, but .NET Core and all this other stuff. Then you have Cobalt Strike's probably biggest addition it's had in the last little while, which is execute assembly, which allows you to take a malicious exe you have on your system as the attacker and push it over your C2 channel into memory of the target and have it run entirely in memory. You just say execute assembly, path to my thing, go. So it's a really, really fun one. There's also a lot of ways that you can run C# code. There's the obvious, you can compile to an exe, you compile to a DLL in those traditional senses, but it starts to get a little funky as you explore the living off the land styles of getting things to run. Before the C# craze really hit, one way that when you're still using PowerShell for everything, if you wanted to get some C# code to run, you could use what's called add type. And I'm going to show a demo of this a little bit later, where you literally add a whole new type of object into PowerShell, and that's just a giant block of C# code, and it runs it for you. My personal two favorite ways of doing it right now, because it flies under the radar for a lot of stuff, is wrapped and lulbind as a .cs proj with MS build. What the fuck does that mean? So what that means is when you use Visual Studio and you build something in C#, you typically have the program or the file that has all your C# code, and that's called a .cs file. A .cs proj is kind of like this XML structured metadata of the program. It has all these traits and attributes about your program in there. And someone figured out that you can actually tuck in C# code into that file. And then what you can do with MS Build is get MS Build to compile and run your CS proj file. So it's just kind of a neat, quirky way to get C# code to execute. And then the way that I wanted to be able to demo for this, but I'm actually building a new C# rat to hopefully release next year, and this is going to be one of the core delivery mechanisms. You can push raw C# code, so like the text that you would have in your program, over the wire into memory of your compromised machine, dynamically compile it in memory of the target, and run it. And there's very little to no artifacts that get left on the system. So you're not compiling anymore. You're compiling it on target, dynamically, in memory only. So what we are going to demonstrate, offensively, is I'm going to show you that CS Proj technique with MS Build. I'm going to show you that you can still accomplish that fun stuff that, for a while you kind of had to do with things like C++, which is process injection. Specifically, I'm going to show you the technique for QUser APC. And then also Cobalt Strike's assembly, which isn't that fun to look at, but just so you can see how easy it is. All right, video time. Not this one. All right, let's do the CS Proj. So I hope we can see this okay. All right, cool. So I'm just going to hit play. This is the inside of a CS Proj file. And basically what you're looking at is this kind of XML structured thing, but what we're adding in is this thing called Task Factory, which is going to add a build task to this file. So that when we hit it with MS Build, it's actually going to compile this file itself. And under that C data, kind of in square bracers, there's our straight C# code that you would normally have in your .cs file. And then when we hit that with MS Build, see it's doing some process injection with virtual alloc and create thread. And then that big kind of byte array up there, that's our actual Cobalt Strike payload. We just pass this file into MS Build. It builds it. We have our access. Speed it along here. So there's the path to MS Build. You say the path to your file. Because I'm injecting it to myself, this particular window is just going to hang there and stay as is. That's some OPSEC you'd probably obviously want to change. But there you go. Gets you your shell. Right? It's pretty straightforward. Next up, let's do execute assembly in Cobalt Strike. So this is a Cobalt Strike window if anyone hasn't seen it before. All the other stuff I'm going to show you is the result from those beacons up there. So what we're going to do here is just, we have a compromised host, and in the bottom left corner where it says beacon, I can type execute assembly, and then the path on my local machine to what I want that to run. And so in this case, I think we're going to do safety cats, which is a really cool mini port of Mimikatz. So you can see it's saying we've tasked Beacon to run a .NET program. I think I'm going to scroll up there. Yeah. So it's saying this is specifically, you can't use this if it's not a .NET PE. Does its Mimikatz thing, grabs some credentials, great. What I love about safety cats is it actually deletes the LSAS bin dump at the end of it, and we got our credentials. All right, let's do APC injection. Why is that so small? Fair enough. So here's a little program I wrote that does APC injection. It's going to kick off a process that I want to run, that I want to inject into. So I have these little, or kind of organized way I like to do my programming. So what we're going to do is create a suspended process with create process. We're going to allocate some memory for it and then write our shellcode into there. Then we are going to open a thread, and we're going to set the memory protections on that to execute read, not execute read write, which is clumsy OPSEC, and then resume the thread. And then that queue, for those who don't know QUser APC call, it's basically you can queue these little tasks within a thread, and then it'll get around to kicking them off. And we're just going to run that to putty, and there's our new shell, APC injection. And then finally, the one, it's old, but I love this. So this is a PowerShell add typing. And for me, and for anyone else that programs, I think you're going to find this cool if you've never seen it before. So here's my C# program, does some recon. I use this to kind of check if I'm in an analysis machine or a sandbox. This is all this code that's in it, so you can see the code right now. It does some kind of checks, generates a unique identifier for the target, and then it goes down to some anti-VM checks and stuff like that. Looks for EDR processes. But that's not the important part. We have this PowerShell script here. And when I open it up, this is a PowerShell script. This is not a C# file. So the very first thing at the top of the line that says $code, that's a variable, right? It's just holding a bunch of text. And that text it's going to hold is the entire contents of my C# program. And what makes this work is when we go all the way down to the bottom, some more PowerShell commandlets specifically here. I have to give it one more assembly, remember we talked about that, to use, specifically the system.management assembly, because I'm using some WMI tradecraft in this tool, and it needs to specifically load that assembly in order to open up that class. But other than that, we just say add type, a reference to any assemblies that are needed, in my case, just the one, and then the type definition is C#. And here's what it looks like. When you import that PowerShell script, it's going to expose the methods and the classes to you. So here's how you access them. Recon was our namespace, if you remember correctly, right? Environmental keys was one of my kind of other classes I had in my program. Let's go back to recon.program, then you do : and it's now exposing my methods. So I have a method called execute, and we run that, and that's C# code, running some reconnaissance techniques right there. Okay, cool. So next, detecting malicious C#. There are no silver bullets here. Like I said, it's very young. I shouldn't say very young. Not widely explored publicly. In the .NET Framework 4.8, which is not out yet, I don't actually have an answer of when that's truly going to be released. It's still as a development branch, but you can download it and run it in your system. Just be aware that it is in dev. Is anyone here familiar with AMSI? Just throw your hand up if you know what that is. Yeah, I know you guys know what it is. So AMSI stands for the Anti-Malware Scanning Interface. It's from Windows, from Microsoft, I should say. It's actually really cool. There's 1,000,001 bypasses coming out for it all the time, so like everything, it's not a silver bullet. But what AMSI does is Microsoft, in all their lovely glory, I don't work for them, so I don't know why I'm saying that, has exposed an API so that if you're a security vendor, or if you just feel like rolling your own kind of antivirus or anything like that, the Anti-Malware Scanning Interface, AMSI, will expose essentially this API to you. So you can have AMSI check stuff out and then report back to your tool. It kind of allows you to hook into the way Microsoft more or less does things. And by default, the provider, or I should say the consumer, for AMSI will be Windows Defender. Doesn't have to be, though. So in 4.8, why do I mention this? Well, in in .NET, there was no real way to scan the code contents looking for malicious stuff unless you have some EDR tool or anything like that that does that. So the most common way, and here's kind of the pitfall of AMSI for .NET, is most malware will load itself from C# using a class called system.reflection. And in the system.reflection, underneath that, you have what's called assembly.load. And you usually pass in a byte array. And that's how you would load in like the byte array representation of a PE file that you want to inject into memory or something like that. So AMSI hooks assembly.load. And anytime assembly.load gets used, it crawls through what it's trying to load and says, hey, I think this is malware, bad, right? Again, these are not silver bullets. Managed code, like .NET, or like C#, running in an unmanaged process. It's kind of weird. Right, so why is this unmanaged process, maybe it's something written in whatever language, all of a sudden has some managed stuff running into it? In order for managed code to run in a non-managed process, it has to load some .NET components, like the CLR. So you can pivot off these things. Another one, like Anselm pointed out, is event tracing for Windows. So Silk ETW is really cool. There's some native .NET libraries that expose event tracing. Event tracing for Windows is like opening up a goddamn fire hose. It is really, really big. If you think of Windows event logs, there's a feature you can go to turn on analytic and debug logging, and you'll just see your log file grow like 10 times the size. It's all those little analytical debug messages. Like anything else, you can still hook those API calls, right? Because it's managed language, sometimes to get to those unmanaged things like create remote thread and virtual alloc, a lot of security tools hook those API calls and watch for things trying to access them. You can still do the same thing with C#. C# can also be reverse engineered very, very easily. It's a managed language. So even with packing, encrypting, and all that stuff, I'm going to show you a demo of like a 3-click process to decompile a C# program right back to source code. It's very easy. It's not really reverse engineering at all. It just takes very minimal effort. All right, so in this demo, I'm going to show you AMSI kicking in right in Visual Studio as I'm coding. And then I'm also, just for shits and gigs, I'm going to patch it and bypass AMSI with a port I just made from PowerShell into C#. I'm going to show you, like Anton did with Silk ETW, just picking up a little bit of stuff with image loading, detecting the CLR with get CLR reflection, process injection with get injected thread, and then reverse engineering a .NET PE with IL Spy. All right, back to videos. Let's do AMC first, because nothing says a good defensive demo like breaking it right after. Okay, why are you doing that? That's a little easier. Okay, so this is a Visual Studio program that is designed to be an AMC bypass, and then it downloads the thing that I want to run now that AMC is out of the way. So that harmless.exe is actually mimicats.exe. Now this will fail normally because you can't just load mimicats.exe this way. So we're going to get two errors. One that, hey, this file doesn't work, that's fine. And the second is AMC kicking in. But just by patching that line marshall.copy, that's actually applying the patch. Okay, they get it, move on. All right, so we're going to run our program. We're going to get some exceptions thrown. First one is like, I don't know what the hell this is, but this inner exception, check out the message on it. That is AMSI kicking in .NET 4.8. Contains a virus. Okay, I still like that we use the word virus. It seems so 80s. And now we're just uncomment this one line, re-download, still going to have an error about the program, but the AMC message goes away. And what the patch is in this case, in case you're wondering, is we're beating AMC to scanning the file, because what happens with AMSI is it returns a code saying bad. We're just patching the code in ahead of time and saying, all's good. And then AMC goes, okay. There you go. That's the whole patch. And by the way, this isn't, probably should have a link in there. Bytebleeder, Marcello from Black Hills InfoSec and the developer Silent Trinity, he came up with this PowerShell method. I just ported it over. So all credit due to Mr. Marcello. Cool. There's that. Here is Silk event tracing for Windows. So I'm going to run that AMC bypass as a compiled program right now. And the reason why I am is it uses assembly.load. Okay, so I want to catch assembly.loads with event tracing for Windows. I run it, and you'll see that'll jump up from 5 events captured to like 12. There we go. So it just caught a whole bunch of stuff. And what's really cool about this time I didn't download Mimikatz, I was downloading Rubius. Let me speed this up a little here. I know it's hard to read, it's all this JSON shenanigans. So we got an assembly load. We see, hey, something called AMC bypass loaded. And if we trace up a little bit, oh, another thing tried to load, Rubius. So it's actually catching both events, not just the normal executing program, but also what it downloaded and loaded. All right, I'm going to move real quickly here. Let's do ILSpy. All right, this is how hard it is to reverse engineer a C# program. So ILSpy, it's completely free. I just have my program loaded right there. I'm going to double-click something. It's going to say I'm decompiling. And decompiled. That's source code right there. That's literally what I wrote in the program. So if you want to look like a really mastered reverse engineer, just only do C#, and then you'll amaze people. That's what I do, and they think I'm good at this stuff. And yeah, you can just deconstruct. There's our bytecode. There's our payload. Everything's just deconstructed. Poof, right away. And finally, let's do some process injection and CLR reflection detections. This stuff's kind of cool. All right, so bottom screen is I have a few payloads running, and I want to see, hey, do I have anything injected on my system? Has any processes had something injected into them? Get injected thread is a really, really great PowerShell script. Anton, Jared Atkinson? Jared Atkinson developed it. So right there it says, hey, MS build, which is what we kicked it off with, has something injected into it. So what I'm going to do is say, okay, that's a good detection. Now let's dump this reflection, this process injection using reflection out. So next tool, get CLR reflection. We just run it. We don't have to pass it a thing. Pass it the process. It'll just know. It'll grab it. And what it does is spits out that hash file right there. It says MS build and then a hash. So what we do is we take that, and I'm just going to dump that into like PE Studio, something real basic. That's not MS build. That's the thing that it was executing. That's my CS proj. We can look at strings. It's got IPs. It's got create thread and virtual alloc and all that stuff. I mean, it's really this whole thing of finding, from a static analysis perspective, bad C# is a 1, 2, 3-step process. It's really straightforward. All right. Key takeaways from this. So that's at the end of my talk. For the offensive folks, shift over to C# from your PowerShell stuff. Main reason is PowerShell is very easy to detect, C# not so much. Operates exclusively in memory. You can do the whole bring your own interpreter thing. So for those of you that are maybe good with Python or Go or Booleang, whatever the hell that even is, all this other stuff, people are finding out all these ways that you can load those engines into your C# tool. .NET APIs are super rich. You almost don't need those Win32 APIs to do a lot of stuff. Interoperability is massive, working with COM, working with other languages. For the defensive folks, don't lose sight that the usual suspects still apply. Process injection is still process injection. Create mode thread is still create mode thread. So look for those usual suspects. Something got created, image loading, CRTs being called. Application baselining is going to be huge for this. And I know AWL, application whitelisting, is very hard for people, but it's worth going. If you understand normal .NET in your environment, bad .NET should stick out like a sore thumb. The list of Windows APIs can still be hooked. AMC can help. 4.8 might take a while before it's in GA. And understanding .NET artifacts, what gets dropped, what gets created, what temp files get made, all that stuff, from an offensive perspective will really help things stand out to you. And that's it. Thank you all so much.
Any questions?
No. Damn it.
Oh, wait. Oh, here we go.
Yeah. Hey, I'm back again. So one quick question I had was, so you were saying about the interpreter, you can bring your own interpreter, bring your own stuff. So is it that you can run practically its own environment? So for Python, you can run your own Python script. If you have a really good malicious Python code, you can use C# to just inject it straight through and run Python, say, on a Windows machine? Or would it work differently?
It's not quite what it means. So Iron Python, specifically, I use that example because what Iron Python, and I don't know who developed it, its purpose was to take Python lovers and then people who want to work with C# and .NET and kind of fuse the two languages together. They created something called Iron Python. So if you bring the Iron Python engine into your C# project, you can start coding in like quasi-Python. So you'll see things that'll look very familiar to a Python structure and how you'd code with it. But it doesn't mean you add the Python engine just right in and you start writing Python. There is Python support for Visual Studio, which allows you to use that as an IDE and then write in Python or something like that with some minimal caveats. But the idea is that there's all these people out there who have been developing these kind of hybrid language engines as a means to bring you in to the .NET world. So it's not as straightforward as like, check the Python box, start coding. It's the guy you really want to talk to is Byte Leader. Like he found all of this stuff. And he's in the Bloodhound Slack and answers every question you could throw at him. But there is an intermediate step that you have to take. So usually it's this engine that supports a little bit of functionality of the thing you want, and then allows you to kind of work with it. So it's not so straightforward, sadly. Hope that answers. Cool.
All right.
No, don't give him the mic.
So I was just going to ask.
Next question.
Yeah. In terms of offensive security, we obviously had a party for a real long time with PowerShell. Because it's everywhere, and Microsoft was pretty slow to build in detections. They seem to be moving a lot faster when it comes to telemetry in .NET in general, not just C#. So how long do you think these tools are going to be viable? And once they up their game, what's the next move? Does it become like a whack-a-mole obfuscation game, or does it rotate to yet another stack?
There's debate right now about, like, do we go deeper into Windows, like with .NET and C# and all that stuff, or these extra interpreters, or do we go so far off the map and do everything in Go and that kind of thing, or do we go right back to C or something like that? The way I think this is going to go in the next few years is exactly how PowerShell went. I think it's going to be no different, just a different thing. I think the visibility and the telemetry and the collection, which is starting, just going slow, that's going to catch up. But even when that caught up for PowerShell, there was a few reasons why people didn't just drop PowerShell. I mean, still, I wouldn't advise anyone to just drop PowerShell from your kit. Just be OPSEC-minded about it. So I think it's going to look the same. It's going to go, oh my God, we can't catch this, to, hey, we can kind of see this stuff. And then it's going to be, hey, we have a thing you can install to catch all of this. So there'll be like the C# version of transcript logging and whatever the hell the other ones are. script block logging and all that kind of stuff. And then we're still going to have that gap of, well, you can't just turn it on, right? So even with something like script block logging or transcription logging, which I love, transcript logs just end up in some folder somewhere, and then people feel better because they turned it on. Doesn't mean they're using the data in any single way. So I think we're going to have a nice long buffer of C# that's catchable but not being caught. And then when that runs out, I mean, so here's one thing I'm paying attention to. Microsoft has said in 2020, allegedly for general release, the .NET Framework, Mono, and .NET Core, and maybe Xamarin, are all going away. It's going to all get rolled under one roof. So what I think about that is, do I stay on Windows with Visual Studio, write in C# or with some adaptation to .NET Core type stuff, and target tvOS or target Android, as opposed to like just changing the target .NET version? So like that to me rings, how the hell are you going to deal with that? Where you try to develop in one or two languages for almost every single platform there is. Like when that hits, I think that's going to be a game changer. Might work against us, but I don't really know. I think we're going to have a nice long road of offensive C# ahead of us, to be honest. My hot take. Thanks, Paul.
All right.
You're a good guy.
Last question. Oh, I got one left. Making me work.
Why do you think it took this long to get to C#? Because it's kind of funny for people who used to code C#. I saw PowerShell come up, and I'm like, well, these APIs have existed for a while, and I figured people were going to PowerShell because it was more compatible, easier to code, and what do you think going back? And do you think it's going to be more of a side grade, or do you think there's going to be a lot of exciting possibilities with C# today, which is obviously much different than a couple of years ago?
So I don't think it's a going back from the offense perspective. I think offensive people are just now being like, oh, we can do this in C# too. They didn't make the connection, and I'm speaking very generally. It's like I said, when you work with PowerShell, you were working with .NET. All the stuff people saw to do with PowerShell just caught the attention of attackers, being like, oh, this gives us all that fundamental access. While we don't have to compile a program, we can just script it out, blah, blah, blah. And then when sort of people realizing like, oh, C# does the same thing, which makes sense. Like you can access run space PowerShell or PowerShell run space in C#. You can do the same in PowerShell for C#, like with add type. It's just like you only know anything once you know it. And then you go, oh, now I know this. That's a thing. So I think a lot of offensive folks just were so enamored with PowerShell because it was so big for the last few years that when the C# thing popped up, it just seemed new, and we're now going over to it solely for two reasons. One, it's just a new challenge, writing in C# and getting your weapons over there, and just the fact that most PowerShell could be caught if you really stepped up the effort. So this just seems like what PowerShell can catch, or what malicious PowerShell you can catch. Right now, in the public space, you can catch this much C#. So it just makes sense. But you're right, it's been around forever. Like, I don't know why it's new. It's just laziness. That's really all it is. Cool.
All right. Thank you very much.
Thank you all so much. I appreciate it.